I want you to get very excited in a minute, but I'm going to give you 30 seconds to know why you're getting excited. If it wasn't for this gentleman sitting up here on the stage, Monty Lundy, none of us would be in this room today. Because I remember we'd all be in the bar, you're right. But it feels like a long time ago in a galaxy far, far away, Monty Lundy had an idea to start the Themed Entertainment Association. And fortunately or unfortunately,
we're stuck with it.
30 companies back then said, yes, Monty, we're with you. And today, as you know, we're over 1,800 companies worldwide. So again, a huge round of applause to our founder, Monty Lundy, and of course, Intel.
So I want to start by commending you all for making it through a 10-hour day of summit. I'm sure that this will be so interesting that our 4-hour session will feel like 35 minutes. Now, we're here to talk about technology. And over the last 20 years, the TEA has recognized 17 amazing technologies for their ability to enhance guest experiences and become incredible tools for the creators of wow, which is what we all do for a living. From a walking dinosaur at Disneyland to interactive magic wands, trackless ride systems, advanced audio and video storage technologies, and RFID flashlights, and 3D video, technological advancements help us influence the way guests perceive and feel. Through the THEAs, the TEA seeks to recognize and highlight those technologies that support the development of ever more mind-blowing events, spectaculars, and immersive experiences. Which brings us to this year's THEA recipient for Best Technology, Intel's Shooting Star drone. Intel is truly taking drones to new heights with their highly programmable, record-breaking advancements in drone technology.
Billions of people around the world have been amazed and delighted by Intel's drone light shows. Some see it as an engineering marvel. Others consider it a new form of art. To make it all come together, Intel has a highly skilled and experienced team of engineers and artists. It starts with site planning, when flight areas, spectator positions, and viewing angles are identified. During this process, the three-dimensional canvas in the sky is defined, and the team is working with aviation officials and other regulatory bodies to acquire the necessary approvals for the drone light show. Every Intel drone light show begins with an initial concept, a story to tell. The story evolves through an iterative and collaborative process of sketches, drawings, storyboards, and music development. Once the direction of the show is defined, the technical work of bringing these ideas to life begins using 3D modeling and animation software. The motion path and trajectories of the fleet of Intel Shooting Star drones are computed by carefully controlling particle simulation. An important element of the drone light show experience is the music. This is also a critical element of the LED animation process, as certain cues to the score will trigger transitions and LED effects. We love working directly with composers on custom soundtracks to make each drone light show unique. The drone light show is considered to be complete when all the LEDs are perfectly choreographed to the soundtrack. Once the composition of the Intel drone light show is complete, testing and validation begins. Intel simulation software helps preview trajectories and the LED sequence of the drone light show. At the show's location, our operations team will have taken care of shipping, infrastructure, build-out, security, and setup, and staging of the airfield. Each Intel drone light show is operated by our team of licensed pilots, professional show controllers, and qualified visual observers. All that's left to do is for our clients and the audience to look up and enjoy the show.
So here to give us the inside story about how these flying pixels create a new type of storytelling, are Anil Nanduri, Vice President and General Manager of Intel Drone Group, and Daniel Gurdon, Chief Light Show Technologist at Intel Drone Group. So Anil, I have to ask the first, I think, obvious question. Intel is known for developing chips and chasing Moore's Law or vice versa. What got you into entertainment and developing drones?
So we're a bunch of chip heads, we got to admit that, right? And it's the first most obvious question that comes is what does drones and chips have to do with it? If you really look at drone technology, and if you look at what it is all about, it's about processing a whole amount of data, whether it's data from sensors, being able to use the accelerometers, the environment information, the pressure, the height, the altitude, the flight planning. And more and more, Intel, if you know, for the last few years has been transforming itself from a chip company to more about from a PC-centric to data-centric. So we are focusing on technologies that drive huge amounts of data. And drone technology is no different from that. From autonomous cars to autonomous air vehicles to drone technology to the elements, what's happening in the edge, where there's a lot of artificial intelligence coming in. So we look at these as extensions of large kinds of new kinds of data that have to be processed. It just so happens that one of the applications where this technology can be applied is to give you a wonderful light show experience in the sky, like a flying pixel. But quite often you'll see drones used for inspections, used for search and rescue. There are many, many use cases, and the fundamental capabilities, whether it's communications, processing, the storage, the ability to have different kinds of sensors, all of them are very much core to what we Intel build and relate to.
Fair enough. So Daniel, there are several drones on the market these days. What makes the Shooting Star so special?
So what is so special about the Shooting Star? It's the one and only drone which is designed specifically for light shows. And the clicker is not working. Here we go. So if you look at the drone, there's no camera, no other payload whatsoever. The only payload it has is the bulb underneath. That's a light bulb. There's a 4-chip LED underneath, which can basically generate any arbitrary color combination, 4 billion color combinations. And the drone, well, if you fly hundreds of drones in the vicinity of people, of course, the first thing we think about is safety. How do you make this safe? And the whole drone design is made to be safe. So if you look, for example, at the propellers, they are flexible plastics. We have cages around the propellers to protect them. The whole drone is made of soft plastics and foam. There is no sharp edges on the drone at all. That's outdoors. We also have the Shooting Star Mini, which is the indoor version of it, like the little brother. And it's also built for safety. It only weighs about 60 grams, so really not much. Anil?
Yeah.
This is how my boss and I like to interact.
So they asked, are they safe? And I'm like, okay, just throw it at me.
Anil gets hazard pay at Intel for doing that. He's their test dummy. So tell us a little bit more about the lighting on these in terms of one versus the other, the mini versus the large one.
So in the end, they are carrying the same LEDs. However, we are driving the LED on the outdoor one much brighter than the one on the indoor one. And you also see that the light bulb on the indoor drone is much smaller than in case of outdoors. However, if you look at the typical scenarios, you've just seen the scenario on a cruise ship where you're really close to the audience, then the indoor drones kind of are visible as bright as the ones outdoors, just because the audience is way more immersed and closer to it. So,
Okay.
And when we looked at this, you look at drones, like you guys have worked from your industry, there's many kinds of drones out there, and as you said it. But if you think about it, it's like, okay, you are thinking about a flying pixel. This is a drone just designed to do that, and do that perfectly, light up the night sky.
Fair enough. So for both of you, what are some of the most memorable shows that you've put on to date?
So this is probably something Anil remembers.
So,
Talking about safety of the drone.
yeah, so when we first designed the Shooting Star, and this, by the way, you just saw the indoor mini safety test, all right, live on stage. But then when we were doing the outdoor, this is a constant question. Safety is the highest priority. So how do you know these are safe? And we were there, and one day I said, you know what? There's no other better answer than just stand right in the middle of it. And I walked right in where the drones were launching and landing, and just stood there, just looking up. And they were just coming all around me, over me. And after that, you know, when we went into the regulators and just said, hey, this is how safe they are, it just, you know, a video says 1,000 words, and it just helps, you know, convey the message that, you know, we really designed around that. That's foundational to how we approached it.
So we always use him to test safety.
Yeah. And by the way, we think about drone, and I think what Daniel, when you think about Shooting Star, you got to think about it as a system, by the way. So because it's not just the drone that's up in the sky, it's the airspace, how you operate, how do you launch, how do you charge them, how do you maintain them. The whole concept from an end-to-end is part of the system, and we'll talk a little more as we go through this discussion.
So are there any other activations that you are particularly proud of?
So when I think back, what was like the most amazing show for me, there was a show we did last summer for Intel's 50th anniversary, and we were flying a new world record, more than 2,000 drones, 2,066 drones simultaneously in the air on this field. And imagine you stand on this parking lot. Usually you would have 100 cars there, but instead of 100 cars, there were 2,000 drones. And then you stand in the middle of it, or right next to the launch field, and they start going up, and like a minute later you look again and they keep coming. And a minute later you look again and they still keep coming. It's just like, wow, that's a lot. That's really a lot. And then you see them all going up there, and you see the night sky from the very left to the very right, and you look up and it's all bright. You can't grasp that. Your brain hasn't seen something like that before. And this, I only have to still get goosebumps just telling about it. It's an amazing feeling looking up there. And this is something I will remember forever.
Tell us a little bit about what at the time was the world record flight at Pyeongchang in China.
Yeah, so there's a couple more actually shows that are memorable.
Oh, really?
We'll get to it before we get to Olympics, because that's a good one. I know how many of you have seen the Super Bowl this year, and so everyone remembers the Lady Gaga jump, and I think someone mentioned it earlier, and that was a few years back at Houston, and we had 300 drones do the U.S. flag, and that was the backdrop for the Lady Gaga stunt that started the show. Just this year, when we had the halftime show, we had a different challenge, and this was in Atlanta. It's an indoor stadium. And we had to do the halftime show, and we wanted to kind of bring a much more intimate experience, which is indoor. For those who think about indoor, there's no GPS, period. Not just that, we had to kind of create a special kind of a modification to the drone to give it a lantern effect. And the thinking behind that was not just about the dome that made these lanterns, but also kind of give it that candlelight effect. So how do you use the LEDs to give you those flickers and beautifully and perfectly choreograph to the music? But when you fly indoors, since you don't have GPS, you need to create a location environment. So you need to create that space for the drones to know where to go. So we do our own technology to build that out. And the challenge there is, I don't know if you know about Super Bowl, it's got 60,000 people on their cell phones. It's got wireless 4K cameras. It's got C-band antennas and transmission stations. Not just one, they have like 2, 3 backups, because this is the world's largest event that they want to have streaming and no glitches. And the amount of police helicopters flying around, which have their own microwave antennas transmitting, and you don't predict when they show up. And you think about the interference of radio frequencies until you're actually involved in it. And for us, the kind of power we use is so little that any of these big frequency bands just wash us out. It's not even the overlap of frequency, it's also the power envelope that happens. So you can just get washed out completely. And so if something you look at it and say, there's 2,000 things that can go wrong, and we are doing this live because it's going to happen, right? And so it comes back and thinks only one thing can go right, and how do you prepare for something like that? And so for me, that kind of a challenge, for me, is a technology challenge. How do you make a solution that can work in such an environment? That's what drove the team, the passion, and everything has a methodology to it. And we were even ghost hunting frequencies. In fact, at this event, for the first half, while everyone's looking at the game, we had a guy with a live spectrometer walking around looking for radio frequencies and saying, what else is happening out there? And so, that's how you get it done. And you got to plan for every eventuality. It was the most perfect animation. So for me, that was a very, very memorable show.
Fair enough.
And it's never been done before. It was 150 drones. It's the highest number of drones flown indoor in any, kind of an environment like that. And plus, given the interference, the level of robustness we had to do was phenomenal.
So can we talk about Pyeongchang now?
Oh, yes. So let's go show, I think, let's give you a video just to kind of talk about what we are referring to here.
This is the largest undertaking for the Drone Light Show team. 1 billion people watched the opening ceremony.
To be at the Olympics, it's just astounding.
We've mostly done shows about 300, so to jump to 1,200 is a big deal operationally. What can we do? What's the most we can do? How far can we push this technology?
Our drones had never flown in such cold temperatures.
We had a team that went to the Alps to test in negative 10, 15 degrees C, basically withstand those conditions to find out what's possible.
Winds are holding good at 1 meter per second.
What you see here is a super lightweight drone that's really the only drone of its kind to be built specifically for outdoor light shows. The Intel Shooting Star can be super bright or very dim with countless color combinations.
Red, green, blue, white.
We have GPS for finding its way path in the sky. We also have a barometer for pressure sensing.
1,000+ drones can be flown by one pilot. And the software behind all of this really makes the magic happen. It's the intersection between art and technology.
Look how far we've come from 100 drones to now we're here and we can say, of course we can fly 1,200 drones. It's a big leap for the team.
We flew at the opening ceremony. We flew at the Olympics. I can't believe that we've had such a great opportunity to showcase our technology here.
Thank you. And again, it was an iconic moment for us, and that snowboarder was actually 300 feet tall, just to put you the perspective in that sky. And behind the scenes preparing for it, again, these are the challenges we look at, and for us, technology is an element to showcase, and the creativity is what the people experience. So as much as the technology is hidden behind, for us, we get more joy, right? So when people from the theme park industry use us and use that animation stories to come to life, we would like to actually be behind and just people wonder how it was done. And here we had to prepare, lithium-ion batteries and cold don't go well together, right? And so we had to test for this kind of environment. And I think the roof was still being constructed, the places were being constructed. I think I'm very familiar to your stories and experiences. And we had to test in Lapland. I don't know if you know where Lapland is, northern part of Finland. It's pretty cold up there. And when Finnish people, we have some on our team, they came to Korea and they said, it does feel cold here. And I'm like, seriously? For the Finland, this is cold? And then imagine me from a tropical country coming in and saying, what should I be feeling? But it was cold.
And the story continues. I mean, what were the learnings we had with this? It's like, we prepared all this and we made sure that we had all the processes in place and we had the technology in place to be able to fly the drones at negative 20 degrees in Pyeongchang. Yeah. And then we were there at the roof and we didn't really worry about the temperatures for the drones anymore because we knew they would work. We worried how we could keep ourselves warm in our fingers.
Yeah.
All right. So I see our 4 hours is winding down here. So Daniel, tell us a little bit about the skill sets of the team that's developing and running the drones.
Well, if you look at the light show, it's kind of a whole production. It's starting from, well, you have architects and designers who think about the whole system, and also not just the hardware and the software, but also the operational aspects of the systems and what kind of technology you need to make that happen and make it a viable product in the market. Then you have an engineering team. The drone is very complex, so it's like a little computer in there, and you have electrical engineers, mechanical engineers, but then also you have the aerodynamic aspect, so you need physicists, you need people who know about aerodynamics, make that happen. And then we have a tool at some point, we have software engineers to complete the software. And then you have this tool, but it's only a tool, so we need you folks out there, we need creative people who use the tool to do something that is overwhelming, that's showing something new to the world, and it's getting people's emotions. And this is where also in our team they come in, we have a couple of designers and animators who then work with that tool and always just keep thinking around, okay, now I have those 3D pixels somewhere in space, what could I do with them? And then, of course, you have the operations team, as we've seen in the video at the beginning, how it works with the whole workflow and processes of creating such a light show. Of course, you need to make sure you need the program project management with the customer on site to make sure everything is in place when the stuff arrives. You have your logistics team bringing the drones in. You have the operations team then running the actual show. And also, we have aviation safety experts, like with decades of experience, which helped us enabling such light shows in 20 countries around the world already.
Perfect. So, Anil, it appears, as part of the award committee, when we saw the initial video that was submitted, we were impressed with how diverse the group was, the management, the engineers, the participants that developed this whole system. Can you tell us a little bit about diversity and Intel's feeling about all of that?
Yeah, I think this is an important and very close to me as well. Technology and science and technology and women in science and technology as well as inclusion has always been a big topic. And we at Intel decided to take this head on. Right? How did we do that? First we said we made a commitment. And this was in 2016, we said in 4 years, we will have equal representation and we'll have equality in that representation for both women as well as other inclusive minorities into the workforce in the technology side. And in fact, when we made that commitment, we didn't even know how to go solve it. And one of the main problems with inclusion is that we find out that it's not about bringing just the people in. Retaining them is also a big challenge. People and women if they either after getting married or they want to kind of start families. So we had different kinds of situations where we had to address. So we took that head on. In fact, we were very proud to announce that we beat that goal 2 years ahead of the deadline. So in 2018, we met that. And just recently this year, not only we met that equality goal, we also made sure that the pay parity goal was also met. So these are the ways we kind of take a commitment, you take a goal and just stay focused and find a way to solve it.
Perfect.
And no different in the drone team, by the way. In fact, one of the best examples is we had a Wonder Woman activation here in LA. And for just given that concept, we just said, we're going to use an all-women crew for operations. And they went and did the whole show from the drone team.
I think that's the video that we saw.
Yeah.
Excellent. So Daniel, what was more challenging, developing the hardware or the software for these drones?
Well, this is hard to say because hardware and software really go closely together, and one doesn't exist without the other, or doesn't work without the other. And sometimes if you can't fix a problem in hardware, you have to fix it in software. If you can't fix it in software, you have to fix it in hardware. And if you look at it from an aviation point of view and aviation safety point of view, you have the hardware, the aircraft, you have the airspace, and you have operations. And the tools you have available is hardware, software, and process to make it all come together, make it a safe thing. And for example, if you talk about safety, of course, first of all, you want to have the most reliable hardware. You make sure that your motors run for hundreds and hundreds of hours without any issues, that your propellers are robust, that the sensors you're using are high quality and they won't fail when the drone is flying, then you have to add some software layers to, for example, ensure the airspace. And we have what we call, for example, the geofence, which is a virtual fence that is limiting our airspace we are using to fly the drones in. And if for some reason a hardware would fail after all and the drone would hit the inner geofence, it would first of all try to fly home. If it cannot do that, it would hit the outer geofence that would just kill the motor and the drone would fall down way before it reaches the audience, right? And there's many of these software features in there to make the process easier, to make operations easier. For example, pre-flight checks. Of course, it's always very important to check the drones mechanically, visually, is anything broken on the drones before they take off. But also we have developed smart algorithms which would automatically detect some typical mistakes, typical errors in the drones.
Like a battery's not charged.
Right, or like one of the GPSs is having a bad reception or so, and the control station would automatically not use that drone, but replace it by a spare one, which is good.
Perfect. Yeah. Pat, I can hear your alarm.
Here I am.
Are we out of time, or can we have?
It's meant for you.
Oh, we're
out.
The bells are
We're
ready
done.
for you.
Well, thank you,
You're out.
Anil and
Monty,
Daniel.
thank
Yeah,
you,
so-
Monty.
Thank you.
Thank
Yes,
you,
thank
Anna.
you.
Thank
And
you,
for-
Annie. Woo!
So, just while we are wrapping up, for those who are here in LA region, we've partnered with one of the theme parks at the Universal. They have an dark arts, activation at the Hogwarts Castle, and we are in that storytelling experience. So, and this technology has been leveraged there. So, I think it's going to be starting this week or something to that regard.
Perfect.
So, for those who are interested, you can definitely go see it over there.
Excellent.
Excellent.
Thank you.
Gentlemen.
Thank you.
Thank you. I know there'll be a lot of questions later. Lynn, are you here to take them out? There she is. Pat, you want to come back up?
I'm coming back up.
We'll do our thank yous and then wrap this up and get everybody to the cocktail party.
Okay. So, thank you, everybody, for being here today. It's a wrap, and we're going to try to do short versions of thank yous to the team, without whom none of this would have been possible, but you've heard that several times today. I'm going to call out a couple groups, but also we want to point to this page in the program. It's doesn't have a folio number on it, but never mind. It must be page 2. There it is. It's page 2 where the names are all written down. The TEA staff, could you stand up and be acknowledged? We want to specifically thank Jenny Nevin, Tammy Richards, our awesome event producer, Erica Schwer, equally awesome associate event producer, Marie Brennan, our PR and publications team, Judy, Ms. Dollars and Cents, Linda Ham, Marty Palicki, and Roberta. We've got the Summit production team.
We've got the entire Summit production team. Please
stand
stand up so we can applaud your great work for today. All the production team, everywhere you're at. Woo! So then we're going to go right to, they're telling me the cocktail party is starting, and we had a Next Gen crew with us today. So please stand up. Let's recognize you for a job well done. All the Next Geners in the room. All right, well done.
Thank you, Next Gen. Particularly, we also want to thank our co-moderators. You all, we are looking forward to hearing what you think. We had Monty, we had Sean, we had Lisa Passamonte, Brian Morrow, and we want to thank all of you for joining us today.
And now, the TEA Summit is a wrap, so go to the NoHo's Mixer, which has started 5 minutes ago. It's in the Mark Twain Room and Terrace at the ground floor of the Frontier Tower. Have a great evening. We will see many of you tomorrow night and then next year for the 17th TEA Summit. Enjoy.